All right, guys, I'm going to start. You don't have to listen to me, but I'm going to start with number 1. I'm punching it into my calculator. Three. Math window. Oops. Alpha window. 5. Shoot, what the heck? Sorry, guys. So you have to go 3. Alpha window 5. Put in your 2. Put in your 4. So it looks like on your calculator, and just press enter. And the answer is 6. That's how you do it on your calculator. So the answer is 6. You don't have to show any work for this. But if you wanted to show work, one thing that you could do is you could go log base 2 and move the 3 to an exponent, which makes that log base 2 of 64. If you look on your family sheet, 64 is really 2 to the 6. The 2's cancel, and that's another way of getting the 6. But you don't have to do work if you don't want to. So does anyone remember the base properties? If you have an exponential base and a log base, they will cancel. And your answer is just going to be x. If you want to punch it in the calculator, you'd go 5 raised to the alpha window 5. Put in base 5 of x. This x right here. Like that? You guys see that? Answer. Oh, it doesn't even give you the answer because it doesn't give you x for an answer. Anyway, so the answer, you need to know that property. This one, again, you cancel the bases, and the answer is 3. If you're punching that one in the calculator, you press log 10. Make sure the 3 is on the inside of the parentheses. The 3 needs to be on the inside of the parentheses like this. It has to be on the inside in order to get the right answer. You guys, there's the first 3 answers. 6, x, and 3.
So you just cancel all the numbers out? You swooped?
I did not swoop in number 1. First of all, the first way I did it was I just punched it straight in the calculator. The second thing I did was I moved the 3 to the exponent and made it 4 cubed. And 4 cubed is 64. So I had log base 2 of 64. And then if you look at your family sheet, 64 is 2 to the 6. And the 2's cancel, and you get 6. That's just a long way of doing it because your calculator will give it to you.
Can we use our family sheet on the test?
Yes, you may use your family sheet. Now the next 4 or the next 2 are just rewriting. There's no calculator needed.
So how do we know, like, on the test that's one of those problems?
It just says, when it says rewrite, no calculator needed. Just rewrite it. So the base is 2. You swoop, and you pick up the 4, and you set it equal to 16. I will take points off if you don't write it correctly, though. Like, if there's lined paper, the 4 is above it, but the 2 and 16 are even. On this one, again, if you had lined paper, you would write log base 3, that goes down low, equals the exponent, and then the 1 over 81 goes right next to log. Equals -4. That's how you write it. 6 and 7 are straight calculator. You do not have to do change of base. Just use your calculator. I'm going to write calculator at the back. I will give you these little hints on the test. I'll say just use your calculator. I'll give you hints. That's why it's important to be here the day of the test, because you don't get hints if you don't come the day of the test. So on 6, we're going to punch it in the calculator. Alpha window 5. Put in the 7. Put in the 14. Looks like that. Press equals. If you do not have alpha window 5, I will show you how to do that right now. You just have to press in log 14 divided by log 7. Log 14 divided by log 7 is change of base. If you do not have alpha window 5, you press log 14 divided by log 7 is the second way of doing it, like that. That's the second way of doing the same thing. Same answer. You can go alpha window 5 or you can do change of base. So 7, you just punch that straight in the calculator. Natural log 0.059.
Wait, 7 we use natural log, right? Yeah.
So that's negative 2.8302.
Negative 2 point what?
Okay, there are the first 7 answers. Okay, 8 and 9. If you guys can get your property notes out, we're doing properties for 8 and 9. So what do you do if you see an addition sign? You multiply. Good. So we're going to multiply. We're going to write the base once. Oops, can't see. We're going to write the base once. And we're going to multiply 12 and 6. So that equals log base 5 of 72. Now, I do not want you to use a calculator to evaluate this. It doesn't ask you to evaluate. It just says write it as an expression as a single logarithm. So it doesn't say evaluate or approximate. So just leave it like that. Now, the next one is a little bit harder. We have lots going on here. We have 3 logarithms. Do you guys see that? 3 logarithms. This 3 is an exponent. So the first thing I'm going to do is I'm going to write log base 7 of x cubed. That's called the power property. I'm not going to do anything to change the second one yet. And I'm not going to do anything to change the third one. The only thing I did for the first one was the power property. For the first one. This one right here. That one right there. Alright, now, the next thing I'm going to do is I'm going to apply the product property and the quotient property all in one step because we're going to go single log now. Single log. If you see a plus sign, you're going to multiply. And if you see a subtraction, you're going to divide. So you're going to go x cubed times y, but you're going to divide x plus 3. This is your answer. So if you see a plus, you multiply the 2 numbers that the plus signs between. But when you see a subtraction, that means anything that's what that log goes in the bottom. You're dividing it. That's all you have to do. You're done. When you're solving for equation, remember, when a single log equals a number, you're going to swoop. That might look something like this. Log of 3x equals a number, like 5. If you say that, you would swoop. That's what that means, single log. So when a single log equals a number, you're going to swoop. And again, this is what a single log looks like. It's on one side, equals a number. When a single log equals another single log, you're going to drop the logs. So you might have log base 3 of x equals log base 3 of 2x minus 4, something like that. That's what I mean by having a log on each side. Okay, a single log on each side. That's when you drop the logs. When an x is in the exponent and the bases are the same, you drop the bases. So you might have a problem like 5x minus 2 equals 25, x minus 4. The reason I can do this one is because I can change 25 to 5 to the second. Now they have the same base, and then you would drop the base. Drop the logs, drop the bases. Swoop, drop the logs, drop. So this whole section right here is from that activity we did on Friday. So if you guys, I can pass that paper out. That whole activity you guys did on Friday is from this section. It's also from your notes, the solving equation notes. And when x is in the exponent with different bases, you're going to take the log. Take the ln of each side. That's when you have something like this. 3 to the x equals 7. You can't get these to be the same base, so you would take the natural log of each side. That's what happens when you do that. All right, here we go. So which case do we have? Let's number these. 1, 2, 3, and 4. 4 is if x is in the exponent with different bases, take the natural log of each side. So I'm going to be asking you guys which case we're in. So in number 10, which case do we have? Do we have a log on one side? Do we have a log on both sides? So we are in case 2. When a single log equals another single log. We're in case 2. We are going to drop the logs. However, so we are going to be dropping the logs. But first, we got to make sure there's no numbers out front of the log. You guys see this 1/2? That 1/2 has to go out up on top of that x, because I can't drop the logs unless it starts out with the word log. So this is x to the 1/2 equals this. So the 1/2's in the way, and the 2 also has to go up here. Log base 3 of 3 squared. I moved those outside numbers to exponents.
So do you always do that?
Yes, and you can't drop the logs unless it starts with log. Like you can't start with 3 log. It has to be log.
So whenever you're going to move something that's in front of log, it always goes to the exponent.
Exponent, yep. Now that you have this nothing out front and nothing out front, now we can drop these logs and set x to the 1/2 equal to, what's 3 squared? 9. Does anyone know, remember, how to get rid of a 1/2 exponent that's in a power? If I need to make that a 1, how can I make that a 1? You guys learned this in Algebra 1 and Algebra 2. You would square it, because 1/2 and 2 are reciprocals. You would raise it to its reciprocal. So you would square both sides. 1/2 times 2 is 1. And 9 squared is 81. And that's your answer. That would be a hard one on the test. I don't think I'm going to give you anyone that hard. I won't give you one with a 1/2. I won't give you one with a 1/2 on the test. If I do, I'll help you out during the test. All right, 11. Which case do I have? It's case number 1, single log. We are swooping. You are swooping. But in order to swoop, you need a base. What's the base? The base is 10. I'm going to fill that in. Fill in your base 10. That's a common log. So if you swoop, it's 10 raised to the 1.4 equals 18x. Now, if you're solving for x, how do you get rid of 18? If you're solving for x, how do you get rid of 18? Divide by 18. So we're going to punch all this in the calculator. I just punched in 10 to the 1.4. I'm going to press equals. And then I'm dividing by 18. $1.3955. 1.3955. There it is again. What case do I have for number 12? Can I change 15 and 4 to the same basis? No. So this is case 4. We're going to take the natural log of each side. So I want to go ln 4 to the x, ln 15. By doing that, that takes that x and releases it out front. And then, since this is being multiplied, we're going to divide both sides by natural log of 4. Punch that in your calculator. Punch that in your calculator. Lucas, put your headphones away.
I think it's on his thermos as well.
Oh. 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 But you said log went quick. It's pretty good. Like, you say rain on the front there. What you walking the door for? What happened?
Wait, is it
Oh, shit! That's live video.
Hey, please tell me that's on video.
It's on video, sorry. Live video, sorry about that. I almost fell. I'm human. All right, natural log of 15 divided by natural log of 4.
Oh, you got relocked it. You told me keys. I'll do it for you.
Here, lock it up. It says which way to lock. Did you push it? Then it's, if you push it down, it's unlocked.
I didn't push it down though.
All right. You just do. All right. This is also going to be case 4. We're going to take the natural log. I don't like writing ln like that, so you're going to see me start writing it like that. That was awkward for me to write it.
Oh, the cursive one?
Yeah. All right. So here we go. We're going to take the ln of this side, and we're going to take the ln of this side. What that does is it releases the x plus 2 out front. Divide both sides by natural log of 3. Get x plus 2 equals, let's punch that in, natural log 5 divided by natural log of 3. 1.649. Okay, so this 7 is going to round that 9 to a 0. What can you see that? That 7 is going to round that 9 to a 0, which rounds that 4 to a 5. So it's going to be 0.4650. Is that just one of them? And then we're going to subtract 2. And it's going to be point. Lucas, how many of your review problems have you done? I'm on 13.
That's a write-up. She's over there on the spot.
I am going to call parents today during class of anyone that's not keeping up.
Put her on speaker. I'll call her. Well, who's that?
Did you say please tell your mom?
Yes, he does.
I'm like, if you're daring me, I will. Okay, log. This is too many logs. 3 logs is too many. This is case 2. There's logs on both sides, so this is case 2. We're going to be dropping the logs. But you can't drop the logs yet. You can't drop the logs until it's a single log on the left-hand side. So we are condensing the left side. We're condensing this left side. So you're going to write log once, and what do I do to x and x plus 1? We multiply them because of the plus sign. Now I can drop the logs. Now it's a single log. Drop and drop. You can't drop it unless there's a single log on both sides. I'm going to distribute the x. This would be considered a hard one because you're going to have to factor. If I put this one on the test, it probably will more likely be a bonus. But it's a bonus that you could do because it's not that hard. But if you can get it, it would be sure good to get some bonus points. So if you factor this, it's x plus 4 and x minus 3 because you're finding factors of negative 12 that add up to 1. So they were either this or this, but we wanted a positive one, so it's 4, negative 3. Now when you set these equal to 0, you're going to end up with x equals negative 4 and x equals 3. Can you guys remember what I said the other day about you can't take the log of a negative? So if you put a negative 4 back into the original, that would be no good. So this is called an extraneous root. So your only answer that's good is x equals 3. These are important problems because these are a lot of these kind of problems are on ACT tests. All right, and the last one is swoop. We got a single log. This is case 1. Swoop. Single log. Again, it's a common log, so put a 10 in. So we're going to swoop 10 to the negative 2.3 equals 4x plus 1. We're going to subtract 1 to the other side and get 10 raised to the negative 2.3 minus 1 equals 4x. Let's punch that in the calculator. 10. Why with this focus? 10 raised to the negative 2.3 equals, and then I subtracted 1 to get that. So that's, I'm going to write that on my paper. So this is negative 0.9950 equals 4x. And my last step is divide by 4. So it's negative 0.2487. If you guys aren't listening to me yet, but you just want the answers, here's the answers to the bottom half. 10 is 81. 11 is 1.3955. 12 is 1.9534. X is 0.5350.
Wait, was 14 negative 2.4875?
14 was negative 2.487.
Would it be, well, why don't you round up, so would it be negative 2.
Well, here's what I did. I punched in 10 to the negative 2.3 right here on my calculator. I got this. Then I subtracted 1 from that and got all of that.
And that 1 is the x, technically.
I'm solving for x, so I subtracted 1.
Oh, okay, yeah.
And then I divided by 4.
Okay. So you want to round that up?
All right, I'm going to do, guys, I'm doing the video in 3 parts. So I'm going to stop the video.